Finally, we have the volume, and we'll create a volume wrangle. I'm going to call this volume wrangle val from spline, and it's going to be pretty straightforward. Um, I think it's not going to be too hard. A bit of Xcode. I could do this in VOPs as well, but it seems much easier and much simpler to do it in Vex. So let's try to explain or go through the process of what we're trying to do. So I'm gonna go to the top view. Let's make sure we can have a look at the spline and also visualize the volume. So this is a top view where we can see the bounds of the velocity volume and the spline. What we're going to be doing on this wrangle is looking for the closest point for this voxel, for instance. We'll look for the closest point on the spline. And what we'll do is we'll assign to this voxel the velocity direction will be equal to this direction. So the direction that goes from the closest point on the spline to the voxel itself. That will give us something very eccentric from the spline, okay, on all directions. So that'll be one of the vectors. And the other vector, if you remember, we will be establishing the global direction as being this direction. What we'll do then is we'll blend this direction and say we'll use the attribute on the curve on the spline, the curve view attribute. We'll use that curve view attribute to create a ramp that will allow us to blend between this direction and these directions. So in the beginning, we will have mostly forward motion, and then after more or less the end of the motion, we will have something more. After half of the spline, we will have something like this. We can either use the curve view attribute, or we can also use the relative bounding box position, which will give us 0 and 1 on this axis. So we can use that attribute also to create our ramp to blend these two vectors. I hope that makes sense and that helps. We're going to be building this now. So let me switch to spacebar 1. So we're in this perspective view. First thing, we need to find the closest point. For each voxel of the volume, we'll need to find the closest point on the spline. The spline is coming in on the second input, so I'll call this reference point, and it's going to be equal to the near point on input 1 based on my position. So now we have that reference point. Let's get its position. So this is going to be a vector. Ref position, it's going to be equal to point from input 1, which is a spline. The attribute we're looking for is position, and we know the number of the point is going to be ref point. Okay, now we'll establish a vector called direction forward, and that's going to be set as we said. So looking at the axis here, the floating nomen, we'll see that it's going to be 1, 0, 0. Okay, the x-axis. Next, we also want to float. It's going to be the curve view or the blend gradient. We can either use the curve view or, as I said, the relative point position. Let's give that a try. Rel, let's call it float. It's going to be blend gradient. It's going to be equal to rel bounding box. Because this is a volume, I think you do need to use this one. rel bounding box 0 at b, and we only want the x component of this. Okay, so we're only interested on this direction. We have our blend gradient, and now we have our direction forward. And let's create our direction out. We can actually, I'll reorganize this when I figure out what makes more sense. But we have the reference point, which allows us to get the reference position, and this will allow us to get the direction out. The direction out is going to be equal to the normalize our position minus the ref pos. So we have direction out. Let's have Control X, direction forward, and we have our blend gradient. Okay, so now what we're going to be doing is establishing the main formula for calculating the final velocity. And it's going to be equal to the addition of vel out plus vel forward. These don't yet exist. We do have those directions, but these velocities will be equal to those directions plus their corresponding speed multiplier. So let's say that vector vel out is going to be equal to the direction out multiplied by something. For now, let's just put it 1. And let's say that the vector vel forward is going to be equal to the direction forward times 0 at this point. And this should give us allow us to at least see the direction out, the velocity out. So let's grab our visualizer or grab a copy of it and paste it here, and let's have a look at it. So this is what you can see. Okay, so now we have these directions kind of going from the spline outward. Okay, and this is what we were going for. Great. Now we know we have that direction, and we know we have the other one, and the idea is for us to control the intensity of that velocity based on that gradient. So instead of having the velocity out be equal to direction out times 1, I'm going to be putting it and say that it's times ramp, and let's say out speed ramp, and I'm going to multiply by the channel float. It's going to be called max speed out. Let me kind of collapse this. Channel ramp, and this is going to be using the blend gradient. Okay, let's create those attributes, those parameters, sorry. So the maximum speed out, let's say it's going to be 2. And as you can see here right now, based on this ramp, we have low speed here and high speed as it gets over there. Okay, that's what this blue to red corresponds to. Okay, we can play with it as much as we want. So let's say interpolation, let's say B-spline. I want to have it slower here, and then I want to have it, there's more of that fast area, higher contrast, so there's a kind of a fast transition happening. So this is something we can now control. We'll do the same thing for the direction forward. So we can actually just grab this up to here, Control C. Let's replace this, Control V, and we'll just say forward, not forward. Probably interesting word, but probably doesn't exist. And max speed forward. Let's hit the magic button again, and now we have the maximum speed forward, and let's say 1, for instance. And as you can see, now we have that blend happening. So we can play with this. So I definitely want to have more speed here, and let's have the forward speed over there. And as you can see, this is what we get. So in the beginning, on this side, we have mostly a motion forward, velocity vectors moving, pushing forward, and then it starts to blend into that. Okay. Pretty cool, right? You can play with this as well. So let's say you want to kind of blend things more over there. But I think this is an interesting setup. So let's kind of give it a bit more. And we're controlling these velocity vectors just fine. Now we do want to keep some curl noise. So that's something I'm going to be doing as well. Regarding these speeds, I'm going to keep them equivalent. So 1 and 1. And I think this makes sense. Yeah, let's go with this. And let's just add our curl noise here. So now we have this one. And we're adding that curl noise. Now we do need to play with the scale of the curl noise. So this is going to represent the intensity. If we bring it all the way down, you'll see we have pretty much the vectors that we had. And then we start introducing some curl noise to it. And I think this is going to be a nice blend between one thing and the other. Just so we have something going on there. Maybe a bit more. I would go for maybe 0.4. Yeah, I think I definitely want to feel that curl noise in there, but now we have that expanding directionality as well. So I think this is, yeah, pretty cool. Now we have our out velocity volume A is going to be here, and this is no longer necessary. So this is our brand new, pretty complicated, I would say maybe complicated. Doesn't seem too complicated to me. It's kind of blending different directions. So let me try to wrap this up again. So we're looking for the nearest point on the spline, and we're looking for its position. Using that position and the difference between the voxel position and the position of the point on the spline, we can use that vector to establish an outward direction, which is this. We set up a pretty generic forward direction, which is this. And then we're going to say that the final velocity is going to be a combination of both velocity, outward velocity, and forward velocity. So after we have those directions, to transform those directions into velocities, we just need to be able to control the speed of it. So multiplying the direction by something, some value. And for that, we use a ramp and a maximum value. The ramp will allow us to kind of map the intensity or the value of the speed based on the x-axis, okay, based on this distance along the box. And that's pretty much what we're doing for both. They do have opposite graphs because we do want to have more of a forward motion in the beginning and more of an outward motion in the end. So we're using opposite graphs. We do have controls for their speeds. If we actually want to have a lot more speed in the beginning, we could kind of just say this is value 2. So this is going to be much stronger with a forward motion in the beginning, and then kind of slowing down into that outward motion. So this is something that we can also play with. I'm going to keep them at 1, and let's see what this is going to give us. But first, let's make sure we save everything, and let's move on to the next lesson.